Paper of the day is Relaxed Operator Fusion for in-memory databases, making compilation, vectorization, and prefetching work together at last. Paper presented the Relaxed Operator Fusion query processing model for in-memory OLAP DBMSs. With ROF, the DBMS introduces staging points in a query plan where intermediate results are temporarily materialized to cache-resistant buffers. Such buffers enables the DBMS to employ various optimizations to exploit inter-tuple parallelism using a combination of vectorization and software prefetching. This allows a DBMS to support faster OLAP query execution and to support vectorization optimizations that were previously not possible when datasets exceeded the size of CPU-level caches. Authors implemented ROF model in the Peloton in-memory DBMS and showed that it reduces the execution time of OLAP queries up to 2.2x. They also compared Peloton with ROF against two other in-memory DBMSs, Hyper and Actin Vector, and showed that it achieves 1.8 times lower execution times. Let's look at the evaluation. Paper implemented ROF in the Peloton in-memory DBMS. Peloton is an edge-start DBMS that used interpretation-based execution engine for queries. They modified the system's query planner to support JIT compilation using LLVM and then extended the planner to also generate compile query plans using the proposed ROF optimizations. They used a subset of the TPCH benchmark in the evaluation. TPCH is a decision support system workload that simulates an OLAP environment where there is little to no prior knowledge of the queries. It contains 8 tables in 3NF scheme. They also use a scale factor of 10 in each experiment, that means around 10 GB. Looking at the contribution, paper focus is on getting prefetching and vectorization to work together efficiently using a newly processed model called Relaxed Operator Fusion, or ROF in short. ROF enables the DBMS to structure the generated query code such that portions are combined together to take advantage of SIMD, vectorization, and software level prefetching. Authors implemented ROF model in the Peloton in-memory DBMS and measured its efficiency with the TPCH benchmark. Their experimental results show that ROF improves the performance of the DBMS for OLAP queries by up to 2.2x, and they also compared two other in-memory OLAP systems, Hyper and Actin Vector, and show that ROF's combination of the query compilation with SIMD and prefetching achieves up to 1.8 times the performance than the two techniques by themselves. Let's talk PS score. Overall, this paper is a nice read, so it gets 9 out of 10 on readability. With 13 pages long, it scores 9 out of 10 on length. The description of their approach is decent, so that makes it 9 out of 10. Industry value and learning meter is average, and the Peloton was a research system which got shelved, so it gets 6 out of 10 on each. Overall PS score is 7 out of 10.